Welcome back, everybody. We're continuing on with Chapter 2. We're up to Part 6 now. In the Chapter 2, all about maps and mapping technologies. At this point, I need to tell you about thematic maps and the type of symbolization that goes into the creation of thematic maps. Now, you have the discussion board assignment where you find a example thematic map and write about it. But for now, I'll tell you a little bit about how to view the point, line, and aerial symbols on thematic maps and how they might be used to either show qualitative information and quantitative information. Are there any rules in cartography? Well, certainly there are conventions, and we'll take a look at some of these. Now, here in your textbook, they have 3 example maps. They're all of California. They're all using county data. Matter of fact, it's all the same data. It's the population of the county in 2015. And here what you see is 3 different techniques to display the data. Now, a map reader may interpret these a little bit differently. It's the same theme, but it's portrayed in different ways. Sometimes there's the old saying, is there more than one way to skin a cat? Well, there might be. I've never skinned a cat myself. But there may be more than one way to depict the same data on a thematic map to convey the theme. All right, so what you have here is you have a dot density map, you have a graduated circles map, and you also have a conventional Choropleth map. Which one works best for you, and why? Here's another example of the dot density technique where one dot equals 10,000 people. So easily the map reader can see that we're the most densely populated portions of the United States and megalopolis and along the West Coast and so forth. It's often said by some people, well, wait a minute, you can't make out individual dots. They all blend together in certain areas. Well, maybe that's part of the theme, saying that those areas are densely packed. All right, here's that dot density map of California by county shown again. I've zoomed in to it here, though. You can see, well, the map reader can immediately see how densely populated Los Angeles County is and around the Bay Area as well. And you do see one dot in some counties kind of stand alone. However, where that dot is placed, though, might not actually be where most of the population is. With these computer-type programs, they just randomly put the dot in there, and sometimes you have to do 2 or 3 different runs of these programs to get the spread of the dots to look fairly reasonable. Again, that's another thing about computer cartography. Here, graduated symbols. Here, the sizes of cities. Here, the circle is in proportion to how large the city size is. So immediately the map reader can see that Baghdad dominates the urban hierarchy in Iraq. Or the California data again, this time with the proportional circles, graduated circles. In this case, somebody usually says, well, wait a minute, the circles all overlap each other. Well, maybe that's good in a way. Then maybe that really conveys the explosive population that you have in particular areas by the size of their overlapping circles. Does this one work for you? You don't have to use graduated circles. You can. Other symbols could also be used. For example, here, motor vehicle deaths. Yeah, you could use a graduated circle. You could use a graduated car in some cases. This one's an interesting map. This is jobs gained or jobs lost, where, of course, the graduated circle is scaled in proportion of how many jobs were gained. And so you see areas in the Sun Belt, whereas opposed to jobs lost. How do you show a negative? Well, maybe a different color one, and so the size of the circle is in proportion to seeing the number of jobs lost. How about aerial symbolization? In your textbook, you have this map of the language regions of Africa. Now, on the thematic maps discussion board, a lot of students are going to make the mistake and call this a Choropleth map. It is not a Choropleth map. It has colors, doesn't it? Yes, but that's not what a Choropleth map is. Here on this map, the color types are not to distinguish magnitude, just differences in kind. It's not a map of apples and oranges, but it's just apples and oranges. In that these are the language families on the continent of Africa. Here you have this light green unit, the Semitic family of languages, which almost all of that is Arabic here, whereas the dark green unit is down here, the language of the Bushmen type language, unrelated language. Now the dark green isn't greater than the light green. The dark orange isn't greater or a greater number or a better language than the lighter orange. They're just to show differences in kind, not magnitude. So it's apples and oranges. Now this one does show difference in magnitude, and this is a good example of a choropleth map from the Greek choro meaning place and pleth meaning magnitude. All right, so here you have the 50 state data, motor vehicle theft rate, so it's not the number of motor vehicle thefts, but it's the rate of them. The cartographer has to determine, well, how many categories do I want to have, and how do I want to break up those categories? Is it every couple hundred, as is the case here, or is it the highest, lowest, divide by 4? Well, how you make those decisions are going to influence what the map looks like. All right, so this is an example of a choropleth map. Now, sometimes students think that the word is choropleth, and I don't knock them for thinking that, because probably in biology class you learned about chlorophyll, the color. All right, it's not chloro, it's choro. Yes, but they're color-coded maps. Yes, well, they don't have to be. They could be monochrome, they could be black and white, or they could use symbols. And the idea is that these aerial units are classified and then coded by an aerial pattern or color. It's easier just to use a color pattern here. So this is an example of a choropleth map. There are some problems in showing this, and again, you have people that are practicing cartography without a license. For one, they imply uniformity within an area. For example, over here in the state of Michigan, is this Michigan? Is this Michigan up here? Yes, it's the Upper Peninsula. Okay, so the theft rate is at least 500 motor vehicle theft rates per 100,000 population. But probably in Michigan, most of that theft rate is probably explained by the southern portion of Michigan, the area around Detroit. I'll bet the theft rate up here on the Upper Peninsula of Michigan is pretty low. But you have to shade in the entire unit the same, so it implies uniformity that might not actually exist. This is an example of a cartogram where the size of the state is scaled in not its aerial size, but its size in population terms. For example, here New Jersey is a small state in aerial terms, but it's quite populous of a state. Whereas a state like Montana, it's aerially one of our largest states, but in population terms, there's not many people living there. Here's another animated version of the the cartogram, in that you can see, well, those urban counties are much larger in population than the rural areas are. So that's an effective way, although it's, am I learning that much from this? During election years where the vote is basically 50-50, it's common to show the cartogram of the electoral votes versus the layout of the states. See, for example, in 2004, you had the red state candidate dominated the country, right? By far the vast, most of the United States voted for the red state candidate. But that's in aerial terms. If you look in population terms, and the electors are based on what the population of the state is, it is very close, pretty well balanced, 50-50, the blue versus the red. And here's another example of cartograms. For example, here are the sizes of economies. Well, North America, United States has ballooned up very large. Japan has ballooned up very large, and Western European countries, whereas countries in sub-Saharan Africa and Latin America at the time, the year 2000, had much smaller economies. And so that's one way to effectively show the information. And this type of thing is included in news magazines and websites and so forth to make a quick impact. How about lines on maps? Let's get this out of the way first. Yes, lines can be qualitative. There might be a little bit of hierarchy. You have political boundaries might be in a hierarchy where you might have the country boundary, the state boundary, and then the county boundary after that. You might have major roads versus minor roads shown, or major rivers versus the ephemeral streams that run into them. But that's just showing differences in kind. Usually lines on map are there just to show you where something is located. Can maps show quantitative data with the use of lines? Yes. And one example is the Flowline Map, where the size of the flow line is in proportion to the amount of the data. In this case, it's migrations from the one region of the United States to another region of the United States. These are sometimes used in cultural studies and to show migration, the volume of migration. It's basically the same idea as the graduated circles or the graduated symbols. It's just that you're using flow lines. I almost never use or refer to flowline maps. Now, the main way that quantitative information is shown on maps with the lines is with what's known as the ISOPLETH or the Isoline technique. Isolines collect areas of the same magnitude. ISO means same, pleth means magnitude. Okay, they connect areas of the same magnitude. Now, the contour lines we looked at on topographic maps, they're a type of isoline because contour lines connect areas of the same elevation. Now, let's take a look at some examples. Here's an example of isotherms. Looks like the cartographer is right in the middle of creating it. He has a spattering of weather stations around. They're all reporting in their temperatures. Where do you put the 80-degree isotherm here? And then later you can color those areas between the isolines. Well, it doesn't have a station that's reporting 80, but this one is reporting 81, and this one is reporting 78. So the line has to be drawn right here, or the computer would have to draw the line right there. And where's 80 here? Well, it's 81 here, it's 78 there. 80 must be there. All right, so these are interpolated lines. Okay, in this case, it's an isotherm. Here's some example. Here's an isotherm map, average temperature for a particular month in 2001. So immediately with the isotherms, you can see the distribution of temperature and the gradient of temperature too. This map like you'll see on weather maps in chapter 4, when we look at some weather maps, the big L on the weather map, that means it's a low pressure area. And these lines are lines that connect areas of equal barometric pressure, so they're isobars. Here, this isochrone map you had back in chapter 1, how many minutes does it take you to drive from downtown San Diego to these different places? And how about precipitation? If you have isotherms for high thermometer, isobars for barometric pressure, how about precipitation? Well, they're called isohyates. And here, this is an isohyate map that shows the result of a huge thunderstorm at Colorado State University, where some places got 10 inches of rain and fewer inches as you get away from the middle of it. Now, this is another map that a student forwarded to me, and he said, is this a Choropleth map? It uses color, doesn't? And I said, well, yeah, but that's not what Choropleth means. In this case, what it is, it's actually an ISOPLETH map. It's a map precipitation. Originally, this is done. The data were collected, and Isolines were drawn. But that's a lot of lines on there. That's a lot of spaghetti. And so what they did was they color-coded in between the isotherms, or in this case, not isotherms, isohyates, since it's precipitation. They colored in there to make it easier to see the distribution and the gradient. And then they removed the lines, because otherwise you'd have a lot of black lines all over the place, and that would probably confuse the reader. Once again, these with cartography, you usually don't notice these things unless there's some type of mistake in there. Here's some practice mapping questions. Well, is there a right or wrong answer to some of these? Some of these I think might be actually arguable, but and is there more than one way to skin a cat? Certainly cartographers have certain conventions that they would probably use for these. I'll let you work on those for a while.